Let's take a look at this example. This is a full proof by induction, and we're going to look at 1 plus 2 plus 3 plus 4, continuing that same pattern up to n. We're going to show that it's equal to n times n plus 1 over 2. The first thing you do in a proof by induction is you show that it's true for n is equal to 1. So I'm going to plug 1 in on both sides. Now in this case, if I were to indicate that n is equal to 1, that's just 1. If n is equal to 3, I'd have 1 plus 2 plus 3. So you go to however many your n goes up to. Now on this side, if I plug in 1 here, I'm going to have 1 times 1 plus 1 over 2. And this is a question mark at this point. We're wondering if that's true. Well, 1 plus 1 is 2. 1 times 2 is 2. And then 2 divided by 2 is 1. So we verified that. It's true for n is equal to 1. The next thing we do, we assume it's true for k. So we got 1 plus 2 plus 3 plus 4 all the way up to, and I'm plugging k in for the n, k is equal to, and I'll plug in k over here, k times k plus 1 over 2. Okay, so we're assuming this is true. And then we want to show that it's true for n is equal to k plus 1. Well, if I were to take k plus 1, plug it back up to my original formula, we'd have 1 plus 2 plus 3 plus 4 plus all the way up to, and I would have a k. I don't know why I can't make k's this morning. Let's try it again. There. Plus, and then I have to go up through k plus 1. And I want to plug in k plus 1 for the n over here. So I'm going to have k plus 1, and then I'm plugging in k plus 1 for the n here. So I have k plus 1, and then there's a plus 1 over 2. So all I did is replace the n's over here with k plus 1. Okay, now we're wondering if this is true. First off, before we really get started, let me write this down again. We'll do a little bit of simplifying over here. So that'd be k plus 1, and 1 plus 1 is 2, so we'd have k plus 2 over 2. Now, what our goal is we want to work with the left side, and we're going to try to use some kind of technique to get it to look like the right side. And if we can, then we've just verified it. Well, up here, we said that 1 plus 2 all the way up to k is equal to this right here. So we're going to replace 1 plus 2 all the way up to k with the right-hand side. So this becomes k times k plus 1 over 2 plus, and then k plus 1. And we're still trying to show that that's equal to the right side. Well, I can get a common denominator over on this side. So I'm going to multiply this together. K times k is k squared. K times 1 is k over 2 plus. And you can always create a fraction by putting it over 1. So I'll put that over 1. And again, we're wondering if that's going to equal to k plus 1 over k plus 2. Now our common denominator would be 2. Since this has a denominator 2, then, and this is 1, then 2 times 1 is 2. So I'm going to rewrite each of these with the common denominator. Now here I multiplied the bottom part by 2, so I have to multiply the top part by 2. So I got 2 times k plus 1, and we're wondering if that's equal to k plus 1, k plus 2 over 2. Okay, now I'm going to do a little bit of simplifying. So I got k squared plus k over 2 plus 2 times k is 2k, 2 times 1 is 2 over 2. And we're wondering if that's equal to the right-hand side. Now that they have the same denominator, I can merge together the top parts. So I got k squared, k plus 2k is 3k plus 2 over 2. And we're wondering if that's equal to the right-hand side. Now this factors as k plus 1 times k plus 2. Now you notice something. It now equals the right-hand side. So that's verified. Now this is proof by induction. You show it's true for n is equal to 1. You assume it's true for n is equal to k. And then you plug in k plus 1 for your n's and see if you can get one side to look like the other side. And if you can, then that's true for n is equal to k plus 1, which means it's true for all values. And that's our example.